cutout box is an electrical enclosure designed to allow a conduit or cable to pass through a wall, ceiling, or floor. These boxes are typically constructed from metal and feature a removable cover, granting access to the internal wiring. When executing the installation of a cutout box, the code provides a series of steps to follow. Firstly, identify the studs or joists that will provide support for the box. Secondly, create an opening in the wall, ceiling, or floor that is adequately sized to accommodate the box. Thirdly, securely mount the box within the prepared opening using screws. Fourthly, connect the conduit or cable to the box. Fifthly, finalize the installation by attaching the cover to the box. Regarding the penetration of ceilings with conduit, some jurisdictions have specific regulations. In certain areas, electricians may not be permitted to penetrate the ceiling with conduit. Therefore, if you have a 5-foot piece of electrical metallic tubing or end running out of the top of a 1900 box, it may not be allowed to penetrate the ceiling depending on local codes. It is important to understand that a 1900 box is a type of surface-mounted electrical box, and it is distinct from a cutout box. The code's concern about preventing a chimney effect is related to fire safety. In the event of a fire within the box, the chimney effect could facilitate the spread of fire to the attic. By restricting the penetration of conduit or cable through the ceiling, the code aims to mitigate this risk. To further clarify the concepts and ensure proper electrical installations, let's delve into some additional details. When selecting a cutout box, consider the material and size based on the application. Metal boxes, often steel or aluminum, provide better protection against physical damage and are suitable for various environments. The size of the box should accommodate the number and size of conductors entering and exiting the box, adhering to fill requirements specified in the National Electrical Code, or NEC. Article 314 addresses the number of conductors permitted in outlet, device, junction boxes, and conduit bodies. When cutting the opening for the cutout box, precision is crucial. Ensure the hole is not excessively large, as this can compromise the structural integrity and create gaps that could allow the passage of fire or smoke. Securely fastening the box to the studs or joists is essential for stability and safety. Use appropriate screws or fasteners that are designed for the specific type of framing material. When connecting conduit or cable to the cutout box, employ approved fittings and connectors. These fittings should be properly tightened to ensure a secure and reliable connection. Additionally, grounding and bonding are critical aspects of electrical safety. Ensure that the cutout box is properly grounded and bonded in accordance with the NEC Article 250, which covers grounding and bonding. This helps to prevent electrical shock hazards and ensures the proper operation of overcurrent protection devices. Regarding the restriction on ceiling penetrations, this is often related to fire-stopping requirements. Fire-stopping materials are used to seal penetrations in walls and ceilings to prevent the spread of fire and smoke. The code may prohibit or restrict penetrations that are not properly fire-stopped. When working with EMT conduit, it is important to follow proper installation practices. Firstly, ensure that the conduit is properly supported and secured. The NEC specifies the maximum spacing between conduit supports in Article 344.30. Secondly, use appropriate bending tools to avoid damaging the conduit. Thirdly, ream the cut ends of the conduit to remove any burrs or sharp edges, as these could damage conductors. Fourthly, use approved fittings and connectors to ensure secure and reliable connections. The 1900 box, also known as a 4-inch square box, is a versatile electrical box commonly used for various applications. It is often surface-mounted and can accommodate multiple devices or wiring connections. When using a 1900 box, follow the same principles of proper installation, secure mounting, and grounding as with cutout boxes. In summary, understanding the purpose and proper execution of cutout boxes, along with the rules regarding conduit penetrations, is essential for safe and compliant electrical installations. Always refer to the latest edition of the NEC and local codes for specific requirements and regulations in your area. Remember that electricity is dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns. Furthermore, consider the environmental factors that may affect the installation of cutout boxes in conduit systems. In damp or wet locations, use waterproof or rain-tight boxes and fittings to prevent corrosion and electrical hazards. In corrosive environments such as those found in industrial settings, use materials that are resistant to corrosion, such as stainless steel or PVC coated conduit. Additionally, be aware of the potential for physical damage to the electrical system. Protect exposed conduits and boxes from impact or abrasion. Use conduit guards or other protective measures where necessary. When working in attics or other confined spaces, take precautions to avoid overheating. Ensure that there is adequate ventilation and avoid working in direct sunlight for extended periods of time. Wear appropriate personal protective equipment such as gloves, eye protection, and a hard hat. Consider the load calculations for the electrical circuits that will be installed in the cutout boxes. Ensure that the conductors and overcurrent protection devices are properly sized to handle the anticipated load. The NEC Article 220 provides guidance on load calculations. When routing conduit or cable through walls or ceilings, be mindful of other utilities such as plumbing and HVAC systems. Maintain adequate clearance from these utilities to avoid interference or damage. Consider the aesthetics of the electrical installation. While functionality and safety are paramount, strive to create a clean and professional-looking installation. Neatly arrange conductors and conduit runs, and use appropriate labeling to identify circuits and components. Regularly inspect electrical installations for signs of wear, damage, or corrosion. Address any issues promptly to prevent potential hazards. This is important to maintain a safe and reliable electrical system. Document the electrical installation, including the location of cutout boxes, conduit runs, and circuit assignments. This documentation can be helpful for future maintenance or modifications. When making any changes to the electrical system, always disconnect power to the affected circuits before beginning work. Verify that the circuits are de-energized using a reliable test instrument. Follow lockout-tagout procedures to prevent accidental re-energization. If you are unsure about any aspect of electrical work, it is always best to seek assistance from a qualified electrician. Remember that electricity is a powerful force, and it should be treated with respect. Following these guidelines and best practices will help to ensure safe and compliant electrical installations. Let's expand on specific NEC articles relevant to cutout boxes and conduit installations. Article 314, as previously mentioned, governs outlet device, pull, and junction boxes, conduit bodies, fittings, and handheld enclosures. Within Article 314, specific sections address box fill calculations, which determine the maximum number of conductors permitted in a box. These calculations take into account the volume of the box, the size of the conductors, and the presence of devices or fittings. Proper box fill is crucial to prevent overheating and ensure safe operation. Article 344 covers electrical metallic tubing, or EMT, which is a common type of raceway used for protecting conductors. This article specifies the permitted uses of EMT, as well as the requirements for installation, support, and grounding. When installing the EMT, it is important to use approved fittings and connectors, and to properly ream the cut ends of the conduit to prevent damage to conductors. Article 358 covers electrical intermediate metal conduit, or IMC, which is a heavier gauge raceway than EMT. IMC is often used in applications where greater physical protection is required. The requirements for installing IMC are similar to those for EMT, but with some differences in the types of fittings and supports that are permitted. Article 352 covers rigid polyvinyl chloride conduit, or PVC. PVC conduit is a non-metallic raceway that is often used in corrosive environments. PVC conduit is lightweight and easy to install, but it is important to protect it from physical damage and to use approved fittings and connectors. Article 356 covers liquid-tight flexible non-metallic conduit, or LFNC. LFNC is a flexible raceway that is used in applications where flexibility is required, such as connecting to motors or other equipment that vibrates. LFNT is liquid tight, which makes it suitable for use in wet locations. Article 300 covers general requirements for wiring methods and materials. This article includes requirements for the identification of conductors, the protection of conductors from physical damage, and the grounding of electrical systems. When installing cutout boxes and conduit systems, it is important to comply with all applicable requirements of Article 300. Article 408 covers switchboards and panel boards. These are large electrical enclosures that contain overcurrent protection devices, such as circuit breakers or fuses. When installing cutout boxes and conduit systems near switchboards or panel boards, it is important to maintain adequate clearance and to comply with all applicable requirements of Article 408. In addition to the NEC, local codes and regulations may also apply to electrical installations. It is important to check with the local authorities to determine the specific requirements in your area. Some jurisdictions may have stricter rules than the NEC, or they may have additional requirements that are not covered in the NEC. It is also important to consider the specific application when designing and installing electrical systems. For example, the requirements for a residential installation may be different from those for a commercial or industrial installation. The environment in which the electrical system will be installed can also affect the design and installation. For example, an electrical system that is installed in a damp or corrosive environment will require different materials and methods than one that is installed in a dry and protected environment. Always use qualified personnel to perform electrical work. Electrical work can be dangerous, and it is important to have the knowledge and skills to do the job safely. A qualified electrician will be familiar with the NEC and local codes, and will be able to ensure that the electrical system is installed correctly and safely. Electrical safety is paramount. Always follow safe work practices when working with electricity. Wear appropriate personal protective equipment, such as gloves, eye protection, and a hard hat. Disconnect power to the affected circuits before beginning work. Verify that the circuits are de-energized using a reliable test instrument. Follow lockout-tagout procedures to prevent accidental re-energization. If you are unsure about any aspect of electrical work, it is always best to seek assistance from a qualified electrician. Regularly inspect electrical installations for signs of wear, damage, or corrosion. Address any issues promptly to prevent potential hazards. This is important to maintain a safe and reliable electrical system. Document the electrical installation, including the location of cutout boxes, conduit runs, and circuit assignments. This documentation can be helpful for future maintenance or modifications. When making any changes to the electrical system, always disconnect power to the affected circuits before beginning work. Verify that the circuits are de-energized using a reliable test instrument. Follow lockout-tagout procedures to prevent accidental re-energization. If you are unsure about any aspect of electrical work, it is always best to seek assistance from a qualified electrician. Remember that electricity is a powerful force, and it should be treated with respect. Following these guidelines and best practices will help to ensure safer and compliant electrical installations. Considering the chimney effect specifically, the concern arises from the potential for fire and smoke to rapidly spread vertically through concealed spaces within a building. Electrical boxes, particularly if improperly sealed or installed, can create a pathway for this upward draft. The National Electrical Code addresses this concern through various requirements aimed at maintaining the fire resistance rating of walls, ceilings, and floors. When a penetration is made for electrical conduit or cables, the opening around the penetration must be sealed with a fire-rated material to prevent the passage of fire and smoke. This is typically achieved by using a fire-stopping caulk, sealant, or other approved material that is specifically designed for this purpose. The fire-stopping material must be listed and labeled for the application and must be installed in accordance with the manufacturer's instructions. In addition to sealing penetrations, the NEC also requires that electrical boxes be securely mounted and supported. This helps to prevent the boxes from shifting or becoming dislodged in the event of a fire, which could compromise the fire resistance rating of the assembly. The NEC also addresses the issue of combustible materials in electrical boxes. Electrical boxes are typically made of metal or plastic, but some boxes may contain combustible materials such as paper or cardboard. These materials can contribute to the spread of fire and should be removed from the box before it is installed. The NEC also requires that electrical boxes be properly grounded. Grounding helps to prevent electrical shock hazards and also helps to reduce the risk of fire. A properly grounded electrical system will provide a path for fault current to flow back to the source, which will cause the overcurrent protection device to trip and de-energize the circuit. This can help to prevent a fire from starting. The NEC also includes requirements for the installation of smoke detectors. Smoke detectors are required in all dwelling units and in certain other occupancies. Smoke detectors are designed to detect the presence of smoke and to sound an alarm, which can alert occupants to a fire and give them time to evacuate. By following the requirements of the NEC and by taking other precautions, it is possible to significantly reduce the risk of fire in electrical installations. Electrical safety is everyone's responsibility, and it is important to be aware of the potential hazards and to take steps to prevent them. Remember to consult with a qualified electrician if you have any questions or concerns about electrical safety.